Frequency of the sound in the metal is 250 hertz. Determine the wavelength of the wave in the air. The formula in your data packet that you're going to use is C is F lambda. They want me to use C for the wave speed. I refuse to, so I use V as F lambda because that's stupid. That's the speed of light. But anyway, and this works for light, but not for anything else. So V is F lambda. V is what, 340? And 250 is the frequency. I believe they're asking you to divide, but it's only one mark, right? Okay, so the sound speed of the sound wave in air enters the pipe that is open at both ends. Diagram shows the displacement. So this is our classic, what is this, our second harmonic of both ends open or something like that. Notice that they're showing this as a graph as displacement to the right, displacement to the left. And this is at one instance here, okay? And so these guys are pushing at this moment, these particles are actually displacing to the right, right? And then these guys are displacing to the left, which is interesting, right? Okay. Okay, so let's see. So really the motion, what I'm trying to say is that the motion of these particles is left and right, and that's what they're saying here. So it's a little hard to interpret these graphs. You have to slow down and think about it and think, oh, what does this mean? Okay, so on the diagram at time t, draw an arrow to indicate the acceleration of this molecule. Okay, so let's see. It's labeled m. Okay, notice that it's displaced to the right. Okay, so if it's displaced to the right, this is simple harmonic motion basically, right? And so the acceleration is the opposite of omega squared times x. Now I don't care, I don't know what omega is, and we could figure it out, right, from what it's like. Basically omega is 2 pi times 250, right? Okay, and we'll use that eventually, but if you take a look at this thing, understand that the acceleration, that's opposite of x, right? So if we are displaced to the right, this thing is going to accelerate, you tell me, okay? Remember that the acceleration is opposite the direction of displacement. So if you're displaced to the right, you will accelerate to the, all right, good enough. So draw an arrow, either right or left, if you want to get it right. And then label letter C at a point where the pipe is at the center of a compression. Okay, so start thinking about these spots, right? Think about these particles. These have moved to the left. These particles here have moved to the right, okay? And then these particles have moved to the right, and these particles have moved to the left. So they could ask you, where is a compression, where is a rarefaction, but that's what you want to think about, right? So from here to here, these things are displaced left. From here to here, this is right, that's rightward. So think about that. See if you can think that through and decide where the compression is, okay? I don't want to spoil it for you because I would do all the thinking for you and then you wouldn't think. You got to think. You must think. That's what you must think about. All right.